So what I'm going to show here is how to calculate the number of ribs to use on the hull. So I'm going to start by just kind of going over some of the rules. You can see these are the IRC, WCC ship construction rules, or the amount of total hard area you're allowed for the ship for the ribs, and the bow and stern area is 15% of the total length, as you can see here. Some other rules: ribs can't be greater than 3/8 inch width, and they can't be spaced closer than 1 inch apart from their centers. And I mentioned the bow and stern hard area, so you can see here, here's a description of what's allowed for the bow, so 2 inches with the contour, and then on the stern it's going to be 1 inch from the furthest point. We're also going to use a stringer, because the ship has a armor belt. So you can see here the rule for stringers should be no thicker than 1/8 inch material. And then when we talk about how tall the windows are going to be, you can see right here that you get up to 3/8 inch thick at the deck rim, and then the bottom of the window is either 1 inch below the waterline or more than 45 degrees from the downturn of the bilge, and I'll show how I kind of do that in a minute. All right, so now I'll do some calculations. So the Scharnhorst, this is the scale length, 64.25 inches. Got this from the ship list. So the first step is figure out what total area would be 15%. So I did this calculation right here where I just took the length and then multiplied it by 0.15 or 15%. So you can see I get a total of 9.6 and change inches of hard area is what's allowed. Then what I'm going to do is I'm going to subtract out the forward and aft hard area, so you get 1 inch in the stern, 2 inches in the bow. You see this calculation right here where I take the total area and I subtract out the hard area. So here I'm going to calculate the total number of 1/4 inch ribs. So 1/4 inch is kind of like the standard, probably the most common rib width that people use. And if you're not sure what to do, it's kind of a safe way to make sure you have a pretty good number of ribs, so the spacing isn't too far apart. So what I did here is I just took that total rib area and divided it by the width, 0.25 for 1/4 inch, which will give me the total number of ribs. What you can see here is that the 26.55. So one thing you want to look out for is avoiding like fractions here. So if I only have 26 ribs, then I'm leaving, a little bit on the table. So if I wanted to change that, I could go and adjust this to like 2.875 for the bow and stern hard area, and then I can get another whole rib out of that. Kind of see how that works. So once I have the total number of ribs, I want to figure out what the spacing would be at a 1/4 inch width. So this is kind of a more complicated calculation. So what I'm going to do here is I take the length and I subtract out the bow and stern hard area because that's really not relevant to the width, the rib spacing. And then I use this round down function to kind of take the whole number here. So just take the 26 instead of the 0.55 because you're not going to use fractions of a rib. And then what I do is I add 1. So if you think about it, we're taking that length and then we're going to divide it by the number of ribs plus 1, pretty much. So just think about if you had a length and you divided it into 4 equal segments, there would only be 3 lines in the middle there. There'd be one at 25%, one at 50%, one at 75%. So even though it's 4 divisions, there would just be 3 dividers between it. So it's kind of the same idea here. And what I did is I took that calculation, so this number right here, and I converted it into something more useful. So inches is just the number of inches, and then I figured out like number of sixteenths to kind of convert this number. So you can see it's right near 0.25, so I expect it to be 4/16 or a 1/4. But if it's a odder number, it can be easier to see it in 16ths because that's what I'll actually measure. So with the 1/4 inch ribs, about 2 1/4 inches apart. So those are pretty close. So I could probably try a different strategy for this ship because it's so long. Likewise, I also calculate the number of 3/8 inch ribs. So again, taking the total rib area and dividing it this time by 0.375, which is 3/8. And then likewise, I'll find out what the spacing would be if I only use 3/8 inch ribs. So you can see here, this is closer to 3.5, which is, that would work, but general rule of thumb is try to stay under 3 inches because when it gets too far apart, when you talk about like rams or adjacent holes next to each other, you want the ribs to kind of be, about 3 inches max if you can. So because this boat is so long, what I'm actually going to do is I'm going to use a mix of 3/8 inch ribs and 1/4 inch ribs. So what I do in this section right here is I'm going to calculate how many 3/8 inch ribs I can use, and then what spacing I want those ribs to be, and then use that as an input to figure out how many 1/4 inch ribs would be remaining, what their spacing would be. So with this boat, it doesn't have a step deck, and the bow kind of curves up, so there's kind of more penetrable area in the bow, so I want to concentrate the ribs in the bow. So what I did is I took a look at the hull and I found out that I wanted to cover about the first 12 inches of the bow with 3/8 inch ribs, to kind of give more penetrable area in the more vulnerable area, more impenetrable area, sorry, in the more vulnerable area. So what I did here is, I picked different sizes, so 8 ribs, 7, 6, 5, and then different spacing, so 1.5 or 1.75. That's a center to center distance. This row I'm calculating how much of the hull that will cover up, so just kind of simple multiplication there. So as I said before, my target's about 12. Then what I do is I want to figure out, okay, so given I use 8 3/8 inch ribs, well, how many 1/4 inch ribs would that use? So I do this calculation here where I'm going to take the total area for ribs and I'm going to subtract out 8 times the 3/8 width and then divide that by 1/4 to get the total number. And then I'm going to use the same kind of a similar round down function here with the same kind of methodology to figure out what that spacing would be. So then I repeat that for the various things, and again, looking for about 3 inches as the max spacing, while also covering 12 inches in the bow. So you kind of see this right here is actually kind of what I think I'll go with. So I'll use 7 3/8 inch ribs. That'll cover a little over 12 inches of the bow. I'll get 16 1/4 inch ribs. You see there's not much of a remainder, so I'm not leaving hard area on the table. And those will be 2.88, so that's about 2 7/8 inch. So now that I have this information, so I got 7 3/8 inch, 16 1/4 inch. Now I'll go to the hull and start marking these out. Okay, getting started here, just kind of show the things I use for this. So to mark the ribs, I'll use 1/4 inch. It's like masking tape. It's also the same tape I use for water lines on boats. So you can kind of see there under the patches. I also use like an 1/8 inch tape. So this is 3mm, so it's actually a little bit narrower, but kind of close enough. And both those you can get on Amazon pretty cheaply. I got a silver Sharpie, since the hull's black. Ruler, got some string, I'll use that for the waterline. And then I got this guy, so this is a 45-degree angle cut. To make this, just measure the same distance from two of the edges and then cut it out, and that'll be 45 degrees. So I already started with a few marks on the hull. Started the stern here. The rule in the stern on the hard area is that 1 inch from the furthest point back. So in this case, it's going to be at the top of the hull. Just sort of try to line the camera up so you can see that mark, this one right here. So that's going to be 1 inch, and so it'll be a vertical line. And then along the top edge of the hull, I marked off the 3/8 at various points. So you can kind of see that. The very front I measured 2 inches back, so just kind of a basic. You can see those marks. And I'll just kind of put tape on each of these lines. Overall, this is going to be a pretty simple hull because you see it's pretty smooth. The only real feature is this stringer here, this kind of edge. So for that, since it's limited to an 1/8 inch, I'll use the 1/8 inch tape here. So I'll get these first few things marked up, and then I'll move to the waterline to mark the bottom of the windows. So now I'm going to talk about how to figure out what waterline I want to use and what freeboard I want to use, which kind of goes back to the float test we did before. So here I have the kind of data sheet that I took from the float test. Unfortunately, it's all kind of scribbled because I ended up doing the float test twice, because the first time I did it, it was dark out and I didn't really do a good job. So you can see those different numbers there. The question is, how do you know what's right? How do you know which one to choose? So I built a fair number of boats. So what I'm going to actually do is I'm going to use the Missouri here, which is a similar boat to the Scharnhorst. It's a bit longer. So this is, I think, 74 inches versus 64 inches. So it's about 10 inches longer, but same general turret layout, same general hull shape. If you compare it against all other ships. So there's no step deck, the bow kind of slopes up. So this one you can kind of see, just kind of take a look at where the waterline is. So overall this boat sits pretty low in the water. You can see the distance above the waterline is just about 1 inch for most of this length here. And if you think, so the waterline's a 1/4 inch high, so generally you want to kind of aim to keep the waterline right in the middle. So realistically we're looking at about 1 inch and 1/8 or so on this boat. So that's kind of a good reference point for the Scharnhorst because it's got a similar hull shape. Just kind of quickly show some other boats. So up there's Agincourt, which is class 5 boat. See, that has a step deck. Kind of take a look at what this is. So for the step deck area where it's stepped down, you can see it's just about 7/8 of an inch to the middle of the waterline there. And I can show Congo as well over here. This one's kind of all shot up. So in this, it's got a step deck, but about 1 inch. So really that's probably about as low as you want to go, about 1 inch. So that's what I'll kind of use when I'm marking out the waterline here on Scharnhorst. So I marked the waterline at the one that gave me just about 1 inch and 1/8, and then those marks ended up being 1 7/8 in the bow, 1 3/16 bow forward, 1 1/8 bow aft, and then just about 7/8 in the stern. And you can see I put a string here and I taped it at the various markers. And then what I do is I just kind of look down the hull and just kind of make sure that there's no really bad kinks in it. When I first did it in the stern, it kind of kinked up a bit. So you can see it's pretty straight. Which is good. If there's a kink, that would mean some of my readings were wrong. So now that I have this, what I'll do is I'll mark out the bottom of the windows. To figure out the bottom of the windows along most of the hull,
So I think back to the rules. So the rules say that you need at least 1 inch of penetrable area below the water line. And remember, the water line is a 1/4 inch thick, and if it's kind of centered on where the water actually is, that would mean there's 1/8 of an inch of the water line that's actually below where this string is. So for kind of a minimum distance from the string, that gives me 1 inch plus 1/8 of an inch, so 1 inch and 1/8. So what I'll do is I'm actually going to mark it probably at more of 1 1/4 inches. That's going to give me a little bit of buffer, so maybe once I build the boat and I drive it around, maybe I find out that the way I built it is heavier than I want it to be. When it gets water in it, that's going to decrease the freeboard. So maybe at the weight I build it, if it's too heavy, the boat might be too sluggish, might not be responsive. So I might want to lighten it up a little bit. Now you lighten it up, more freeboard's going to show, but then the bottom of the windows is actually going to move up too. So if you mark the water line with kind of no buffer, then you're setting yourself up for the chance that if you kind of guessed your weight wrong, that you're going to have to cut out the windows again in the future when you decide that you want the boat to be lighter. And for a boat like this, it's kind of long. This is going to be kind of a stern gun centric boat, so mainly trying to shoot the triple sterns most of the time. So it's not really a boat that I'm going to be using the side mounts on much. So in that sense, the bottom of the windows doesn't really matter as much, because if I have a lot of boats shooting me with side mounts, that means I'm probably driving it wrong. So you lose, there's less risk of taking extra damage, really, if the windows are deeper than they need to be. Alternatively, on a boat like Congo here, you can see with the guns, this is just a side mount boat, and you can see kind of all the damage on it. So something like Congo, where I'm primarily using side mounts, that means you're primarily going to take damage from side mounts, which means that the bottom of the window, you don't want to give too much extra away. So, 1 inch minimum. So in this boat specifically, I have probably like 1 1/16 inches, I think, below the water line. But you wouldn't want that to be like 1.5 inches or more, because then you'll take kind of bonus damage that you don't need to take because it's allowed to be hard. So you can see, I'll actually show you Courbet over here. So if you look at Courbet, you can kind of see when I cut this out at first, I actually cut the windows deeper than they really needed to be. And you can kind of see the different colors there in the line. So I ended up, after the fact, I decided that I could run the boat deeper. I ended up fiberglassing from the inside to kind of, and then recutting it level to kind of make sure I only had the required amount of penetrable area. So cutting the windows, it's something you want to get right, but if you mess it up, it's really nothing that can't be fixed. And then if you have to err on the side of caution, I'd recommend, if you're not certain, cut the windows a little bit deeper. That kind of gives you a margin, because if you get to a battle and then you end up running the boat lighter than you planned, and you don't have the required 1 inch below the water line, then that's just not a good place to be, because everyone tries to. There's a lot of self-regulation, and you want your boat to be in accordance with the rules for kind of fair play. So I'm going to mark that out for most of the hull, and then I'll show how I mark the 45-degree turn towards the stern. So I'm going to show how to cut the 45-degree, because in the stern area of most boats, the way the hull curves in, they usually curve in before you get to 1 inch below the water line. So the rule says, either 1 inch below the water line or the 45-degree turn. So how do you figure out the 45 degree? So I showed this before, but what I do is I cut kind of a very basic 45-degree angle. I snip the end off, but to make that you just measure the same distance from one corner down two edges and then cut. Then what you do is you just kind of hold it up against the hull there, and then just put a mark right where it touches there. And then you sort of just do this, every few inches down the hull. And you can see the point pretty clearly there. So you do that, make some marks, and then tape it off. So I taped the bottom off. You can kind of see it there. You can see how it curves up a little bit in the stern, but because the boat's kind of so deep, there isn't actually a huge impact between the 45 and the 1 inch. You can kind of see there, I actually ended up going 1 3/16 down most the length of the hull, so give me about a 1/16 of buffer. Then up in the bow I went closer to 1 1/4, because the bow is because it's kind of at the extreme end. If I ended up wanting to get the stern down a little bit lower, then the bow is going to come up, so that'll give me a little bit more buffer there. So now the next part will be marking out the ribs. So to do that, I think I had 7 3/8 inch ribs and I had 16 quarter. So what you do is you really just kind of start measuring from the hard area, whatever your distance is, and then kind of just make a mark. And then I'll just use the 1/4 inch tape for the 1/4 inch ribs. For the 3/8 inch ribs, I'll probably just overlap the 1/4 inch tape because it's easier to work with, but you could also use the 1/4 inch and the 1/8 inch, or whatever you desire. So I got all the ribs marked out in tape. You can kind of see here. Nice even spacing. So just taking the dimensions I got from the spreadsheet, just measured out starting the bow, went to the stern. You can kind of see in the stern that the last rib spaced out a little bit more, just kind of an accumulation of error down the length of the hull, but overall pretty minor. So on the stringer here, so you're allowed to continue the stringer to the next rib beyond the feature, so the feature ends right here, so I'll continue it to that one, and then similarly on the bow. So you can kind of see the effect of those 3/8 inch ribs in the bow, so you can see where the hull's going to kind of stick up the most, where the most target area is going to be exposed. The ribs are much tighter, which will help prevent rips, and then deflect a few more shots. Really not a huge deal, but for a longboat like this where you have a lot of ribs you can play with, it kind of makes sense to do that. So after I get this one all cut out, I'll show a few other hulls that are more complicated, where this one's pretty simple. So pretty uniform, got the stringer, more concentrated ribs in the front. So the next step will be just repeating the same process for the other side. So now I have both sides marked out. The next step is going to be drilling holes in each of the corners of the windows. And that's going to help when cutting with the Dremel. It'll just kind of help break the pieces off easier and have cleaner corners. Because this boat's got a stringer, I'll have to drill holes, both above and below the stringer. Typically use a 1/8 inch drill bit. Drilling through this much fiberglass is going to wear the bit down, dull it out a good amount, so You might want to pick up some extra 1/8" drill bits just to use, because you will wear them out after a haul or two. So another thing I'm going to do at this point is I'm going to rough up the inside of the hull. So the reason you do that is, this is fiberglass, so once it's cured, if you don't rough up the surface, then when you're adhering doing other fiberglass or epoxy jobs, or adhering goop or E6000 or whatever your adhesive of choice is, it won't stick well if the surface is not roughed up. So I actually just use the Dremel for that. So what I'll do is I'll kind of turn it on, and then I'll kind of go over it, kind of like a sweeping motion like this. It actually works really well and is really effective at roughing up the surface. I'll probably hit it with some sandpaper too, but the sandpaper generally doesn't work as well as the Dremel. So I'll pretty much rough up the whole bottom, and then I'll also rough up this top edge here, which is where the deck is going to attach. The reason why I do the top edge now before I cut it out is, once you cut it out, it gets a lot harder to kind of just quickly move the Dremel side to side, because it'll catch on the ribs. So that's why I'm going to take care of that now. I'll also cover some basic PPE that I use whenever I'm using the Dremel, and specifically with fiberglass. So I use safety glasses. With fiberglass, I'll use a respirator. You can use a dust mask, but it's going to be less effective against fiberglass. So these next few operations create a ton of dust, so it's better to wear the respirator. I also use double hearing protection. When I do this work, I'm in an apartment. It's in a sealed off area, but it's still directly adjacent to my living area, so I'll use a shop vac to kind of suck up the dust immediately at the point of creation. So I usually have one hand on whatever the tool is, whether it's a drill or the Dremel, the other hand with the shop vac, sucking up the dust. I mean, you'll still get some dust, so you want to make sure if you have other boats in the area, get the decks on, because the dust will kind of settle everywhere. If you do this outside, that's great. I can't, so I'll make sure I have the window open. I have like fans, one blowing in, one blowing out. A fan next to me kind of blowing it away, and then also an air filter, which kind of helps keep the dust levels down and protect my lungs. Even if you do this outside, I would recommend using the shop vac, because without the shop vac, it really makes a huge mess. All the holes are drilled out on this side. You can kind of see them there. I also finished roughing up the inside, so you can kind of see the contrast there. So I'll still probably hit this with some sandpaper to kind of even it out, but the Dremel does a really good job at kind of cutting it up, cutting that outer layer up, so you hit the fibers to adhere to, and some of the hard to reach places, like where the keel is there at the very stern, you'll have to get with sandpaper or a different bit on the Dremel. Look at the whole deck edge. So at this point, I'm going to start cutting. What I use is the Dremel. It's kind of standard. I've been using it for 15 years or so to do this, 17 years. So you see it's got a cutoff disc. This is a reinforced cutoff disc. These are the ones I use. I got them from Amazon, I think. I build a lot, so I go through a lot of cutoff discs. So I don't know if this was a pack of 100 or what, but it was a lot. It's lasted me a while. And then kind of going through this process, cutting out the hull. Usually expect to go through 2 to 3 cutoff discs because they'll kind of wear down as you cut more, and then sometimes they'll shatter, which is why the eye protection and then your kind of face protection from the respirator or dust mask will kind of help. I've certainly, over the years, I've been hit in the glasses, on the respirator, with the wheel kind of flying off sometimes. The other common tool people use will be oscillating multi-tool. I've used one for different projects, but I don't have one here, so I've just kind of stuck to the Dremel. The people that do use the oscillating tool, a lot of people really like it, so maybe I'll try it in the future, but for me the Dremel works fine. So the way I'm going to approach this is I'm going to cut all of the same edge moving down the hull at the same time. So for instance, I'll cut all the bottom cuts first and then go down the whole length of the hull, and then I'll cut one side of the rib and I'll go all the way down the length of the hull, and so on. So what that does, I found that's kind of the most efficient, because you'll end up holding the tool at the same angle and just sliding the hull down as you go. Another thing I do is I always try to angle the cut, because the wheel's going to have to go in at an angle for a lot of these spaces, so I'll always angle it away from where the edge I'm cutting against is. So what that's going to do is it'll make the cross section of the ribs more like trapezoids than squares, so they'll be the 1/4 inch in the front, but then they'll be kind of wider in the back, and that will make them a little bit stronger. I'll do the same on the stringer here, so I'll kind of, the bottom cut I'll angle like this, and then the top cut I'll kind of angle like this, and just do that on each edge as I go. You'll see with some of these smaller windows up here, I won't be able to really, if you look at kind of the diameter of the disc, I won't really be able to cut very deep, so I might need to cut from the inside as well, or do kind of like a cross pattern, and then kind of do more of a just breaking it off or grinding it away than like a clean cut like you'll see on most of the main windows. Overall, this is still a pretty simple hull to do. There's no casements, so besides the stringer, it's pretty routine. And then what I'll do is, you'll notice the Dremel wheel spins a certain direction, so when I'm using the vacuum, I always make sure at the point of contact with the hull that it's spinning towards the vacuum. So it'll kind of make sense when you see the dust come off of it, it'll go right towards the vacuum. If you have the vacuum on the other way, it'll still catch some of the dust, but it'll kind of catch less because the dust will be moving away from the vacuum suction. So I'll videotape some of this, you can kind of get the feel. I expect this hull will probably take a couple hours of dremeling to do both sides.
When using the Dremel, you have to be careful to make sure it doesn't jump. It'll have a tendency to kind of catch and dig in, so you'll see me brace the Dremel. So you have to be especially careful when you're getting close to the rib or a stringer, because if it jumps, it can actually cut through and nick the edge of that rib or stringer. When you're making the last cut for a window, you always want to be careful because when it breaks free, it's more likely to cause the wheel to jump. So just when you're making that cut, try to make it on a joint that's less critical, or if it jumps, it's going to jump into the bottom or something where it doesn't matter quite as much. At this stage, I've cut out all of the major windows, but you see some of the smaller ones where I can't really get the Dremel through all the way. I'll have to do more of a cross pattern and then, cut it into smaller pieces and then break those pieces off. The windings of the Dremel will heat up sometimes. Well, when that happens, I'll use the vacuum to kind of suck some additional air through the fan, which will kind of cool it down a little bit. You also just need to sometimes go slower or, break a little bit between when running the Dremel because it'll overheat. It'll be really hot to the touch. After I've removed the pieces, I'll go back and kind of clean up the edges and some of the pieces where maybe I ripped the window off. I'll just kind of clean up the edges and make sure I cut them to the tape lines.
After 3 hours, I am just about done. So, see the boat all cut out. Definitely took me longer because of the stringer and then cutting out all the small pieces above the stringer. Just going to show the finished product. So I'll kind of leave the tape on there to make sure that I cut them all down to the right size. And once I cut it once, then I'll go back and kind of trim up all the edges and stuff on the inside. I'll show you where I kind of messed up a few times. So see that rib there. Ended up digging into it a little bit when I was cutting the other side. Not a huge deal. Stuff like that kind of happens. Now all the scrap pieces, you can see I just kind of threw them out. For this boat, since the windows are kind of small, there's really not much value in keeping the scrap pieces. If it was a flat-sided boat with bigger windows and they were flat, I'd usually save some for like drag discs to cut drag discs out of. One thing you want to look at after you're done is to kind of make sure that the rib thickness is good. If you know off the bat before you cut it out that the rib thickness isn't good, you might want to add more fiberglass to the inside before you cut it out, because then you only cut it out once. But a lot of times the hull might look thick, and then when you go to cut through it, you realize that there are some thin areas, so you got to reinforce them. They'll sort of just show these ones. So this is a nice thick hull. You can see these are all, I don't know, over 1/8 of an inch thick, so it's kind of a a good benchmark, about 1/8 of an inch. If it's a boat that's kind of like a slugger that is going to be taking a ton of damage, then you probably want to err on the side of thicker ribs. If it's like a cruiser, it's really not going to take a ton of damage, then thinner's okay. You can also kind of see the trapezoid effect a little bit on these. You can see it kind of flares out. It's a little bit wider in the back as a result of the angle that I cut them at, and that'll make them, the ribs in the stringer, a little bit stronger. So I'll show the Fuso here just as a reference for how kind of difficult the cutting the windows out can be. So you notice this boat, it's got casements, it's got a stringer, it's got bulges. So some different things here. If you notice in some of these areas here, there's actually 2 stringers between ribs, which means that the deck rim here can only be 1/4 inch instead of 3/8 of an inch. So you can see that for all those portions, and then the area where there's no stringer or only 1 stringer, then you can go to 3/8 inch. I'll show the casements too. So casement rules can be kind of complicated. What you'll notice is there's the curved part here. It's like the cupola or cupola, which was the area that kind of housed the gun barrel, if you look at pictures of the ships. So that area is allowed to be impenetrable, and then you get 1/8 of an inch on either side. Kind of see there. And then you get the stringer at the bottom. It's 1/8 inch thick. What you can see, I kind of move the ribs at the casement deck to line up with the corners here. That will help with shooting. So to cut those out, that's more of like drilling a hole than using a grinding type of bit to get through there. And that's about it. You know, sometimes you'll see people with additional impenetrable area in the casements, which is really not in accordance with the rules. They'll have kind of like maybe like an additional step here or something. But you know, you only get 1 stringer, so 1/8 inch total thickness for the casement deck. So you have to kind of make a little sacrifice of scale to meet the intent of the rules. So this will be the end of the video on cutting out the ribs. This is one of the steps that I like to do first, because you can see really how messy it is, and then also it's nice to get it out of the way. I'll make a different video kind of about different build sequences. Some people will choose to cut the ribs out at the very end, which is fine, but the way I build things, if I waited to cut the ribs out till the very end, then that would cause a lot of issues, make a lot more steps that I do more difficult. Other people, of course, find other ways to work around those issues. You know, I like cutting them out because it's easy to get access to the inside for some of those smaller areas where you can't really get the wheel deep enough. Also, if you look in the stern, how narrow the stern is, you know, when you're cutting through there at the bottom, the wheel's going a decent way into the hull, so if my rudder mount was already installed, I'd have to be really cautious not to cut up the rudder mount as I'm putting the wheel through. And you could say the same thing about along the deck edge, because you'd certainly risk cutting into the bottom of the deck. So I like to get this out of the way, and then, you know, from here, the next main steps are going to be kind of figuring out what internal layout I want to do for the major spacing of the components, and then I'll move into installing the drivetrain. Hope this video was helpful. I look forward to the next one.